Today we will do Unit 1, Electrostatics, Chapter 1, Electric Charges and Fields. So from the name of the unit itself, electrostatics, it comes from two words, electro and statics. Electro come from the words electric field or electricity, and statics come from the word means stationary or at rest. So electrostatics means in this unit we will deal with all those charges which is at rest or stationary. Now when we are small kids, we used to rub the ruler in our head for some time. We rub the ruler in our head. Then after rubbing it, we bring it near to the pieces of paper. We could see the pieces of paper get attracted towards the ruler. Why the pieces of paper get attracted towards the ruler? The reason is because when we rub this ruler into our head, it is like we charge the ruler. And when we bring it near to the pieces of paper, because of the differences in the charges between the pieces of paper and the ruler, the pieces of paper get attracted towards the ruler. Now let's see the definition of electric charges or electric charge. According to William Gilbert, charge is something possessed by material objects that makes it possible for them to exert electrical force and to respond to electrical force. What does this one mean? It means that every material object we have something what we call charge, and because of this something what we call charge, it makes the material able to respond to the electrical force, or we can say to exert to the electrical force. I hope it is clear. Now let us go to the next topic, that is the types of charge. Types of charge. Types of electric charge. There are two types of electric charge, positive and negative. Positive is commonly carried by protons, and negative is commonly carried by electrons. One more thing we have to remember here is that like charges repel each other and unlike charges attract each other. What does it mean? It means that positive and positive charge, negative and negative charge, they repel. That means they go away from each other, and positive and negative and positive, they will attract. That means they will come closer to each other. They will come nearby to each other. Now let's go to the next topic, that is unit of charge. Unit of electric charge. The SI system or the international system of the unit of charge is Coulomb. So SI system or international system of unit of charge is Coulomb, which is denoted by a capital C. Now let us try to define 1 Coulomb. To do this, let us take the example of a conductor. For example, if we have this conductor, to this conductor we allowed a current of 1 ampere to flow through it for a time of 1 second. I repeat, a current of 1 ampere flowing through it for a time of 1 second. Then we can say that the charge present in this conductor is said to be 1 Coulomb. I repeat, if we allow the current of 1 ampere to flow through the conductor for a time of 1 second, then the charge present in the conductor is said to be 1 Coulomb. Now the value the value of the basic unit of charge. The value of the basic unit of charge is given by E, which is equal to 1.602 192 into 10 to the power minus 19 coulomb. This value E is equal to 1.602 192 into 10 to the power minus 19 is said to be the basic unit of electric charge. Now let us go to the next topic, that is the basic properties of electric charge. Basic properties of electric charge. There are three basic properties of electric charge. Let us talk one by one. The number one is charges are additive in nature. I repeat, charges are additive in nature. Number two, charge is a conserved quantity. Number two, I repeat, charge is a conserved quantity. Number three, quantization of charge. Number three, quantization of charge. Let us see them one by one. Number one, charges are additive in nature. Charges are additive in nature. What does this one means? This is a property by virtue of which the total charge of all the charges present anywhere on the system, we can get them by adding them algebraically. That means we can get all the charges which is present in the system by adding them one by one, like 1 plus 1 plus 1 and so on and so forth. Algebraically, it means that we have to consider their signs also. Now, to make it more clear, let us take an example. For example, if we have a conductor here, let us say this conductor, it has two charges, Q1 and Q2. Then what is the total charge of this conductor? We write it by Q, then it must be equal to Q1 plus Q2. Let us take another example. Suppose we have a conductor here. In this conductor, we have n number of charge up to Qn. Then the total charge of this conductor is said to be Q1 plus Q2 plus ... up to plus Qn. I hope this property is clear. Now let's go to the next property. The next property is charge is a conserved quantity. Charge is a conserved quantity. Charge is a conserved quantity. So, according to this property, conservation of charge is the property by virtue of which total charge of an isolated system remain constant or remain the same. That means, according to this property, you can not create or you cannot create charge, or you cannot destroy charge. So charge is a conserved quantity. That means it will remain constant for a body. But we can have one thing which is called transfer of charge. That means it is possible for us to transfer the charge from one body to the other. Now, to do the transfer of charge, for example, let us take two methods. Number one is conduction and number two is induction. Let us see the first method, that is conduction. Let us see conduction method. Conduction. In this method, we should have two bodies. Let us say body A and body B. Let us say one of the body here is charge body. Let us say body A is charge body and body B is neutral body. Now, according to this method, what happened? Next step, what we should do is that we will bring body A and body B to be in contact with each other. The moment body A and body B are in contact with each other, some of the free electrons from one body will flow to the other. In this case, the free electron from B will flow towards A. That means the free electron will start to flow from one body to the other. As a result of that, what happened? You will see there will be some charges appear, some positive charge appearing in B. Let us write more charges in A. Then in that case, some will remain in A. So this type of transfer of charge is said to, or it is called conduction. Now the next one, let us talk about another method, that is induction. In the case of induction method, we must have a body here. Let us say a body A. At this point of time, body A is neutral. That means equal number of, by neutral it means that there will be equal number of positive charge and equal number of negative charge. So as a result of that, the whole body is neutral. Now what happens if to this body A, which is neutral, if I bring a body B? Let us say body B is a charged body. I bring body B near to body A, but body A and B should not touch here. So what happened? We will see that those free electrons which is present inside A, they will start to shift towards one side. In this case, they will shift towards B, and they will create the far side from B to be positively charged. So here, if you look at A, it is polarized. One side is positive, another side is negative. Now what happened here is that, you see, next step, if you have this positive and if you have this body A here, let us say this is A, this is B. Now if you connect body A to the ground, what happened? You will see some of the free electron from the ground will start to flow towards body A, and they will neutralize the positive charge of body A. And as a result of that, if you remove body B, then body A will become a charged body. Let us say now it will look like negatively charged body. So this method is called induction method. Now let us see to the next property, that is property number 3, quantization of charge. of charge. Quantization of charge. The quantization of electric charge is the property by virtue of which all free charges are integral multiple of the basic unit of charge represented by E or by the basic value E. Thus, charge Q of a body is always expressed as Q is equal to NE. So, by quantization of charge, we mean that charge is a quantized quantity, and it is, or it can be expressed only as integral multiple of the basic unit of charge E here. The basic unit of charge E. So, that means we can write it as Q is equal to NE for all the bodies. So, or we can say for all types of bodies, where N is an integer. N is an integer like 1, 2, 3, or sometimes minus also, and so on and so forth. And one thing we must remember by quantization of charge means that charge of a body cannot have like half of E. This cannot be happen. Or also, for example, Q cannot also, for example, have like root 2E like this. This also cannot be happen. For all the bodies or all the substance or element, we will have the charge in this form. Q is equal to NE, where N can be 1, 2, or 3, or any number. But it should be as a multiple of the basic unit of charge, E. So with this, we complete the topic today. Thank you.